Okay, in this video we're going to look at triangle side angle relationships. And the first thing we're going to look at is something called the triangle side inequality theorem. Now we've already looked at this a little bit in class. The triangle side inequality theorem says the sum of any two sides of a triangle must be greater than the length of the third side. So if we're given three lengths and we're asked, can these three lengths make up the sides of a triangle? Well, the way that we can determine whether these three lengths can make up the sides of a triangle is we have to use our triangle side inequality theorem. So according to the side inequality theorem, the sum of any two sides must be greater than the length of the third side. Well, let's add up each pair of two sides and see if it's greater than the length of the third. So for this example number 1, 5 plus 6, that's greater than the length of the third side, so that checks out. Let's see, 5 plus 8 needs to be greater than 6, and yep, that's greater than 6. And 6 plus 8, that needs to be greater than 5. 14 is greater than 5, so yes, in all three of these cases, the sum of any two sides is greater than the length of the third side, so these three lengths can form the sides of a triangle. Let's take a look at example number 2. 8 plus 9, in order for these three lengths to be the sides of a triangle, needs to be greater than 19. 9 plus 8, however, is 17, and 17 is not greater than 19, so no, these three lengths cannot be the lengths of the sides of a triangle. Even though if we went on, we could see that 9 plus 19 is greater than 8, 8 plus 19 is greater than 9. However, since we found a case where the sum of these two sides is not greater than the third side, we know those three lengths cannot be the sides of a triangle. Example number 3. 10 plus 2 needs to be greater than 12 in order for these three lengths to be a triangle. Unfortunately, 10 plus 2 is not greater than 12. It's equal to 12, so no, these three lengths cannot be the sides of a triangle either. Notice that it's not good enough for the sum of two sides to be equal to the third side. They have to be greater than the third side. Now, another relationship between sides and angles in a triangle says that for any triangle, the largest angle is always opposite the largest side. The medium angle is opposite the medium side. And the smallest angle is opposite the smallest side. So let's take a look at how we can use this relationship between the sides and angles of a triangle. In example 4a here, it says, in this picture, list the angles from smallest to largest. Well, on first glance, this looks like kind of an odd question because it's asking me to list the angles from smallest to largest, and yet I'm not given any information about the angles. I'm given information about the lengths of the sides. However, armed with what I know about the side angle relationships, I can figure out the angles from smallest to largest. Since I know that the smallest sides, let me go ahead and list the sides in order from smallest to largest. The smallest side would be side AB. And let's see, the medium side would be BC. That's 6 centimeters. And then the largest side would be AC. That's 7 centimeters. So that's smallest side, medium side, largest side. Well, since I know the smallest angle is opposite the smallest side, that means the angle opposite AB, let's see, that's angle C. That must be my smallest angle. My medium angle is opposite my medium side. Well, BC is my medium length side, so angle A must be my medium angle, and angle B must be my largest angle. So I've used the lengths of my sides to determine the angles that I have from smallest to largest. And you have another example in your notes, and I'm going to let you do that one. I'm going to take a look at this first one under 4b. This one says, list the sides of this triangle from shortest to longest. And again, notice it's asking me to list the sides from shortest to longest, but it's giving me information about the angles. So once again, I'm going to first write down my angles in order from shortest to longest. So let's see, my shortest, or rather my smallest angle is angle B. My medium angle is angle C. And my largest angle is angle A. Well, since I know my longest side is opposite my largest angle, I've got side AC must be opposite angle, or rather my shortest side is opposite my shortest angle. So since my smallest angle is 47, my shortest side is going to be AC. My medium angle is angle C, which means that my medium side is going to be side AB. And my largest angle is angle A, which means that my largest side is going to be side BC. And now I've listed my sides in order from shortest to longest. Now, examples C and D also make use of this side angle relationship of triangles. Example C, it says, for the problems below, draw triangle ABC and then list the sides of triangle ABC from shortest to longest. So I'm just going to do the first example here, and I'm going to let you do the others. Draw triangle ABC. Okay, so I've got angle A is 37, angle B is 48. So let me draw this triangle here. We call this angle A, angle B, angle C. The measure of angle A is 37 degrees. The measure of angle B is 48 degrees. The measure of angle C, it doesn't tell me, but I can use my triangle sum theorem to figure that out. So 37 plus 48 is 85, and if I subtract 85 from 180, then I get 95, which tells me that angle C must be 95 degrees. Now I'm trying to list the sides from shortest to longest, so I want to start out by listing my angles from smallest to largest. So my smallest angle is going to be angle A. My medium angle is going to be angle B. And my largest angle is going to be angle C. So small, medium, large. So therefore my sides, the shortest side is going to be opposite the smallest angle. So my shortest side is going to be side BC. My medium side is opposite my medium angle, so that's going to be side AC. And my largest side is going to be opposite my largest angle, so that's going to be side AB. And now you have some other examples like this one. I'm going to let you finish those. I'm going to move on to example D. Example D says, draw triangle ABC and then list the angles from smallest to largest. So here I'm given, for triangle ABC, I'm given these three side lengths. So let me draw, again, let me draw triangle ABC. And let me fill in my information here. The length of side AB is 9 centimeters. Length of side BC is 10 centimeters. And the length of side AC is 15 centimeters. Now I want to list the angles from smallest to largest, but since I don't have any information about my angles, I'm going to have to first list my sides from shortest to longest. So let's see. My sides, my shortest side is going to be side AB. That's 9 centimeters. My medium side is going to be side BC at 10 centimeters. And my longest side is going to be side AC, which is 15 centimeters. So I have shortest, medium, and longest sides. So if I want the angles from smallest to largest, my smallest angle is going to be opposite my shortest side. So let's see, AB, that's my shortest side, so my smallest angle is angle C. My medium angle is going to be opposite my medium side, so that's BC. And angle A is opposite BC. And my largest angle is going to be opposite my largest side, so that leaves angle B. And now I've written the angles in order from smallest to largest. And again, there are a couple more examples for you to work out in your notes, and we'll take a look at those tomorrow in class.